So is my screen visible?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So what, can you tell what we have discussed in the last class?
The pH of some biological fluids, sir.
For the pH.
Blood plasma 7.4,
Mm-hmm.
gastric juice 1.25 to 3,
Mm-hmm.
saliva 6.35 to 6.85.
Okay. So next, I think we discussed about pKa, right?
Yes, sir.
Yeah. What is called as pKa?
Acid dissociation constants.
Can you speak a little louder? Am I audible for everyone?
Yes, sir.
Yeah. Okay.
Acid
Yeah. Now fine.
dissociation constants, sir.
So I think we discussed the pKa value for different common functional groups, right?
Yes, sir.
Yeah. Can you tell what's the pKa value for carboxylic acid?
4.5, sir.
4.5. Okay. So what is for carbonic acid?
6.4 or 10.3.
So why two values?
There are two hydrogens, sir.
Absolutely right. Okay. So I think you have some basic idea about the pH and pK, right?
Yes, sir.
So this lecture is going to be the continuation of the previous one. Okay. So if you remember a few classes before, we discussed about water solubility and lipid solubility. Do you remember?
Yes, sir.
I mentioned about which interaction is important for water solubility and which type of interaction is important for lipid solubility. Do you remember?
Yes, sir.
Yes, sir.
Yes, I think we discussed about different types of molecular bonding, intermolecular bonding. So in that lecture, specifically, I mentioned that which interaction is important for the water solubility and which is important for the lipid or organic solvent. So can you tell which interaction is important for water solubility?
Dipole-dipole bonding, sir.
Okay, so dipole-dipole. Example for dipole-dipole. Can
H
we
bond.
say hydrogen bonding is an example for dipole-dipole?
Yes, sir.
H bond, right? That's what I have written. Okay, what is which bond is very important for the molecule to get soluble in organic solvent?
Induced dipole. Van der Waals, sir.
Okay, induced dipole, absolutely right. Who is answering?
Aishwarya, sir.
Who is answering?
Aishwarya,
Okay,
sir.
so it's Van der Waals interaction. Okay, it's Van der Waals interaction. Is my screen visible?
Yes, sir.
Yes, right. So these are these are concepts which are very important to study about solubility of any molecule, right? So we are interested on drug molecule. So solubility of drug molecule in water and lipid. For water solubility, the dipole-dipole interaction, ionic interactions are important. For lipid solubility, induced dipole van der Waals interaction is very important, right? So there's one more thing that is very important for the solubility of the molecule is ionization. Okay, uh, so that is why we are studying about the pH and pKa. Okay, so the pH and pKa, right? So these are two important parameter that is going to decide whether the molecule will be in its neutral form or will it be in its ionized form, right? So I'm going to write some formula, right? So what we have discussed in the previous class, pH is equal to negative log of H plus ion concentration. Okay. So also we discussed about pKa. The formula for calculating pKa is equal to what is pKa? pKa is negative log of Ka. And what is this Ka? What's the formula for this Ka? Ka is equal to, already we discussed in the previous lecture how to calculate the Ka value.
Sir, concentration of the H3O plus and concentration of the
So,
conjugate
con-
base.
so okay, I write the reaction here. So say the reaction is Ha plus H2O. That gives H3O plus A minus. If this is the acid base reaction, can you tell the Ka? What's the Ka? How to calculate Ka for this reaction?
Sir, concentration of H3O plus
Concentration of
H3O
H3O plus
into concentration of A minus
into concentration of A minus over
divided by
okay
concentration of HA.
Ha, right? So please make note of this. This already we have discussed. Anyway, very important for today's discussion also. So this is how to measure the pH, how to calculate the pH, and this is the formula used for calculating pKa, right? So this equation, we can simplify this equation, or we can say the simplified version of this equilibrium reaction is we can write this simply as Ha, which gives H plus A minus. Both the reactions are same, right? So one is actual equilibrium reaction, the another one is the simplified equilibrium reaction, right? So even if I mention the reaction as the second one, you have to remember that. So Ha is acid, there is a base, something like water. So reaction is going like H3O plus A minus. Both the reactions are almost same. Is it fine? Looking for kind of a response.
Yes, sir.
This is what actually we have discussed in the previous class, right? So I'm going to write another reaction, Ha, same reaction what I have written here, Ha. Okay, so there's a equilibrium, H plus A minus. Okay, so what we can understand is this equilibrium, this double-headed arrow that dictates that the reaction can proceed either in both the direction, forward direction, or it can goes in the reverse direction, right? So can you tell? So here we have three species. So can you tell which of this is acid? Which of this is acid? Shashank.
Sir, HA, sir.
Am I audible?
Yes, sir.
Yes, sir.
Acid. Which of these three species is acid?
HCA, sir.
HA, sir.
Hmm?
HA, sir.
Can you people speak a little louder? I don't know whether problem on my earphone. Am I audible?
Yes, sir.
Yes, sir.
Okay. So which of this can I say this as acid? Ha?
Yes, sir.
Okay.
Yes,
So
sir.
have you heard about another term called as conjugate base?
Yes, sir.
So which of this is conjugate base?
A minus, sir.
A
Minus.
minus, right?
Three.
So one second, right? So I think I have some problem with my earphone. I'll change and come back, right?
Okay, sir.
No, earphone on கொடுங்க madam. சறுக்குனா தான் நல்லது, டைம் போயிரும்ல. Hello. Am I audible?
Yes, sir.
Still, I am not able to, hear you people. Am I audible now?
Yes, sir.
Okay. So which of this is conjugate base?
Three, sir. A minus.
Okay. Hello.
Yes, sir.
Yeah. Which of this is conjugate base?
3, sir. A minus.
Am I audible now?
Yes, sir.
Yes, sir.
Okay. Sorry. So can you now tell which one is the conjugate base here? In this reaction, which one is the conjugate base?
A minus, sir.
Okay, A minus is the conjugate base, right? I'm going to write another, simple equation. Okay, so the equation goes like this. So the equation is B H plus. Okay, so the reaction is equal going in forward and backward direction. H plus plus B minus, right? So what's the name for this? If this is conjugate base, I hope I'm audible. If this is conjugate base, what's the name for this?
Conjugate acid.
This is acid. This you said as conjugate base. Good. What is this?
Conjugate base, sir.
Conjugate?
Base. Ayo,
Then
acid.
what is
Sorry.
this?
Sorry, sir. Acid.
conjugate acid, right?
Conjugate
So
acid,
okay, let me clarify this. I just erase this. Conjugate acid, am I right? If
Yes.
this is a conjugate acid in this reaction, so let me write this is the first reaction and this is second reaction. The second reaction, what's the name for the reactant?
So BH plus,
BH plus is
the conjugate acid. It's a reactant.
okay, conjugate acid, right? So
Yes.
this is conjugated acid, conjugate acid. Which one is the base here?
So is it B minus?
B minus. Who's it?
Sir Harish.
Yeah, B minus is the base. Okay, just please make note of it, right? So this is a very fundamental, basic organic chemistry, right? So we have taken two reactions and we're trying to understand which is acid, which is the corresponding conjugate acid, conjugate base. In the second equation, the reactant is conjugate acid, and so this B minus is the base, corresponding base, right? Okay, so let me erase all this, right? So we'll try to understand few more concepts before going for solving some problem, right? Okay, so we are very clear about which is conjugate acid, which is conjugate base, so on. Okay, so yeah. So can you tell now in the first equation, okay, which species is in its protonated form? I write here protonated form. So the question is, the first equation, which species is in its protonated state? You know what is protonated, right? Am I audible? Am I audible?
Yes, sir. Yes, sir.
Okay, see, you can respond, right? So I have some issue with my microphone. Please respond. So I am writing two species here. Which one is in its protonated state and which one is in its deprotonated state?
Sir, are you asking in the reactions you've written or in the structure you've drawn, the black ink now?
Here. I am making the concept simple, right? So here I am asking.
Sir, the first structure which has the OH is protonated form, sir. The second
Can you
one-
speak a little louder? I have some problem with my,
Hello.
volume is very less.
Can you hear
Yeah.
me, sir?
Yeah. Speak as much louder as possible, right? So problems with my, microphone.
Yes, sir. The first structure
Yeah.
with the OH group is the protonated form, sir.
Protonated, and the second one is
Deprotonated.
deprotonated, right? So if you apply the same thing for this equation, for the first equation, which one is in its protonated state?
HCA, sir.
HA. So we can say this is protonated, right?
Yes,
What about
sir.
this in the second equation? In the second one, can we say this as in its protonated form? Am I right or wrong? Can we say this as unprotonated form?
Yes, sir.
Yes, sir.
Yes, right. Okay. So this is a few things related to acid, base, conjugate base, right? So protonated form, unprotonated form, right? So why we are talking about all this? Because we are going to solve some problem, right? So I'm going to introduce a equation called as Henderson equation. You might study this in your 12th standard probably. HENDERSON Henderson Hazel-Balch equation. So this equation is considered as one of the very important equation in chemistry. because this is the equation which relates pH and pKa. So far we discussed, I gave a lot of example for pH and pKa. So pH and pKa, which is going to decide whether the molecule should be in its ionized form or in its non-ionized or neutral form, right? So the equation that relates the pH and pKa is Henderson-Hasselbalch equation, right? So what we are going to do is we are going to derive the equation. It's very simple, right? So already we saw the equation for calculating Ka. Ka is equal to H plus ion concentration times A minus ion concentration over Ha. Am I right? Am I right?
Yes, sir.
Yes, sir.
Can I rewrite this equation as, I hope my handwriting is somewhat readable. So can we rewrite this as H plus and base form by acid form? I
Yes,
just
sir.
rewrite in a different way. Does it make sense?
Yes, sir.
See, I'm looking for response from everyone because
Yes, sir.
this is after meal session. Huh?
Yes, sir. We can write it.
We can rewrite, right? Okay, that's fine. Or can we write this as? Does it make sense that can we write this as Ka is equal to H plus ion concentration times base form over acid form? Does it make sense?
Yes, sir.
Just I'm writing a different way, right? So nothing we do. Can we rewrite like this or not?
Yes, sir.
Is right? Okay. So now if I take log on both sides, so can I write this as log Ka is equal to log H plus ion concentration plus log base form over acid form? Is it right?
Yes, sir.
Yes, sir.
Is it right or wrong?
Yes, sir. Yes, sir.
Yes, right. Okay. So I can rewrite slightly this like negative log Ka, because I just wanted to bring the pK into picture. So negative log of negative log of this H plus ion. Okay. So is equal to negative log Ka plus log base form over acid form. We are bringing negative, because pKa is negative log K. Can we rewrite like this?
Yes, sir.
Is it right, or maybe some mistake also, right? So purposefully I can also make some mistake intentionally. You have to tell whether this is right or wrong. Is it right?
Yes, sir.
Yes, right. So what is this negative log hydrogen ion concentration, H plus ion concentration?
Which?
pH.
pH, right? So we can rewrite this as pH is equal to negative log of K is
pKa.
pKa, right? So we just got the pKa here plus log of base form over acid form. Is this equation understandable?
Yes, sir.
Yes,
Yeah,
sir.
this equation is what is called as Henderson-Hasselbalch equation. Please note it down, everyone. I'm trying to sync the class notebook, right? So maybe from Monday you won't be having any problem, right? So whatever I'm writing here, you can see it on your notebook, right? I'm trying to sync it. Anyway, just make
Sir,
note of this, right? So this,
can you scroll
yeah,
up a little bit?
scroll up, yeah. I give some time, just copy, right? So I give you a minute time for you. Copied?
So just a minute.
Yeah,
Just
no
a
problem,
minute.
no problem. Just let me know once completed, right? Yeah, because these equations are very important. We are going to solve some interesting problems, right? So which are related to pharmacokinetics and the entry of the drug molecule into the biological system. So these are the equation, these are very important mathematical formula that is going to decide whether the molecule can dissolve in water or whether the molecule can enter into the circulation or not. And we're going to solve some problem. So once copied, just let me know, right? So I'll go further. Actually, we are slowly entering into the core part of medicinal chemistry. So far, whatever we have discussed, very basic things related to the organic chemistry or drugs, right? So hereafter, all the lectures will be slowly will get enter into the core concepts of medicinal chemistry. Have you noted? Shall I go further? Am I audible? Yeah, shall I?
Yes, sir.
Somebody asked time for copying. Have you copied or not?
Yes, sir. Yes, sir. Sorry, sir. Sure, sir. Thank you.
Okay, fine. Yeah, I just go for the next concept, right? Okay, so what I'm going to do is, before solving the problem, so I just wanted to, draw some structure. So say, for example, if we have some structure like this, C double one O OH. The first question is, can you tell how many number of carbon in this structure? I just wanted to see your understanding about the structure first. How many number of carbons present in this compound?
Sorry, excluding the R part, I guess it's 2.
Excluding the R part, okay, fine. Excluding the R part. My question is also excluding the R part. How many number of carbons do you have?
Yes, sir. It's 2.
Two, right? So okay, so we have
I
one
guess it's
carbon
2.
here and another carbon is here. Absolutely right, right? We don't know what is the R. R may be any group, functional group, right? So say, is it in its acid form or base form? Now the given structure, is it in its acid form or base form? Acid form, right? So absolutely right. So this is an acid form. How do you say it is an acid form?
It has the carboxylic acid functional group, sir.
In terms of what we have discussed so far, can you tell? We discussed about protonation.
That's the presence of the protonated
Okay,
OH.
so we can say this is a protonated form, right? Can I say this same thing as unionized form? Both the same, right? Okay, three things. One
Yes,
is
sir.
it is in its acid form. Okay, we can say it is in its protonated form. We can also say it is in its unionized form. All the three almost refers to the same thing. So now the question of interest is, can you tell what is the base form of this molecule? What is the unprotonated form of this molecule? And what is the ionized state of this molecule? Is my question understandable? So what I need is what structure I have to draw here. If you say this is acid, right? So if we allow this acid to interact with water, say, What will be the product of this? So can we say this will be the product? C double bond OO minus. I'm really looking for some response, right?
Yes, sir. Yes, sir.
Huh?
Yes, sir.
Yes, right. So can you people speak a little louder at least for this class? I have some problem with it. I am not able to hear you. Everyone voice is very, very low. Speak as louder as possible, right? So can we say this is the base form? Yes, this is a base form of this acid. So this is unprotonated. There is no proton here, right? So the H plus is cleaved from this molecule, and also it is in its ionized form, right?
Yes, sir.
Okay, fine. So now I think it's time to solve some problem, right? So as I said, no, we are slowly entering into the core concepts, right? So hope everyone is having calculator, right?
Yes, sir.
Yes, right. Okay. So I'm going to draw a slightly complicated structure, but very interesting drug molecule, right? So let me draw the structure of this drug molecule. So far we discussed with very general concepts like HA. Those are not real molecules, right? So let me give some real-time example. So say I'm drawing structure of one of the very interesting drug molecule, NH. Double bond O is here, double bond O, and another double bond O is here. Okay, so say two bond is here. It goes like this. Okay, so yeah, this is the molecule, and this molecule is called as amobarbital. Very interesting drug molecule. So is it in its acid form or base form?
Sir, acid form.
So who said?
Sir, Harish.
Okay, acid form. So how do you say it is in its acid form?
Sir, it's in its ionized form, sir.
Okay, so can you tell what is the base form of this molecule? What structural difference I had to make here
Sir, remove the
to say it
H.
as a base form? So let me copy
Remove.
this and paste again. Control C, Control V. Yeah. So I made copy of this. I just want to convert this as a base form. What should I do?
So remove the H, which
Remove
is
this
bonded.
H, right? Okay, so if I remove this H, what will happen? Is this structure now correct, or should I make any change in the structure? I remove the H.
Or N minus.
N minus, right? So absolutely right. Very good. I appreciate your answer. So this is one form, right? So what's the name for this? Can we say this is conjugate base? Can we say this is the conjugate base of this acid? Amobarbital is in its acid form. Can we say this is the conjugate base? Right or wrong?
Yes,
Yes,
sir.
sir.
Yes, right. So good, very good, right? So we are let me define the problem, right? So I'm going to define the problem as at a pH of 7.4. Okay, what is the percentage? What is the percentage ionization of the given drug molecule amobarbital? Again, I read the question. Okay, so at a pH of 7.4, what is the percentage ionization of amobarbital? That's the question, right? So can you tell how to solve this problem now? So whatever we have discussed so far, right? So those pieces of information enough for solving the problem. So can you tell how to approach this problem? How to solve? Which equation we have to use? Which formula we have to use? The question is at a pH of 7.4, what's the percentage ionization of this molecule? That's all. So I simplify this. So if we have a solvent or the environment which is having the pH of 7.4, okay, how many number of this molecule will be in its ionized state? That's a question.
Sir, first we should convert the pH into the concentration of H plus ions, sir.
pH into?
Concentration of H plus ions, inverse log. So E powers. Anti-log of 7.4 would give the H plus ion concentration, sir.
Okay, so what I can do with that H plus ion concentration?
Sir, divide that with the initial concentration, that is the concentration of unionized amobarbital.
No
And into 100.
concentration is given here. Okay, the no concentrations are given here. You had to think, right?
Sir, we
The
can take it as
concentration.
X, sir.
Hmm?
We can take that X units of amobarbital have ionized.
Okay, so if I want to apply this equation to solve the problem, what are the values I should know?
Sir,
So this is a formula: pH is equal to pKa plus log base form by acid form, right?
yes, sir.
If I had to use this equation for solving the problem, okay, here the base form, acid form, it has the details about the ionization, right?
Yes, sir.
So base form is ionized form. Here I mentioned the acid form is unionized. Do you agree?
Yes, sir.
So base form is ionized. So I can say that base form is the ionized form and the acid form is unionized form. Okay. So if I want to use this equation, Henderson equation, to solve this, what are the values I need actually? The pH is given, right?
Yes, sir.
If we know the pKa, can I solve this problem?
Yes, sir.
Yes or no? I don't
Yes,
know
sir.
how many of you understanding. How many of you connected? Let me check first, right? Because so many students connected, right? So I am getting response only from one student. Is it Shashank?
Yes, sir.
Yes, right. So what about others? Anybody with the name Ashwin? Anybody? I think almost everyone is responding, but you had to participate in the discussion, right? So otherwise, okay. So if I want to use this equation, right? So what I need is I need the pKa, right? Do you agree? pH is given. I need the pKa. So can you make a guess of what will be the pKa of this? Okay, I just give, right. So because the first problem, I just give the pKa of this molecule. The pKa is 8.0, right? So let me define the pKa. The pKa of this drug is approximately 8.0. Can you now solve the problem? pH I have given. Okay, the pH is the environment. Okay, the pH of the environment is given and the pKa of the drug molecule is given. Can you now tell how to solve this problem?
So we can substitute this in the Henderson equation.
Okay, can you substitute in the Henderson equation and come up with the answer? I can give 5 minutes time for you.
Yes, sir.
Can you do? Everyone just practice, right? So anyway, I am going to tell the answer at the end, right? So I'm expecting some correct answer, right? So let me check, right? So I can give maximum 5 minutes time for you from now. So on my clock it is 4 o'clock, right? So maybe 4:05, right? So before 4:05, just tell me what's the answer for this problem. So once if anybody solved, you can type in the chat, right? So I can enable. Just type in the chat box, right? So once if you completed. Anybody trying?
Yes, sir. 1 minute.
Okay. So simple, right? So everyone can try. Just you have to substitute the value of pH and pKa in this equation. That's all. Just tell me the answer, right? So let me check. How many of you are able to solve? What I need exactly is percentage of ionization. I hope you know what's the meaning of percentage.
கட் பண்ணி வச்சிருக்கிறேன். ஸோ இதை வந்து என்னது அந்த அப்ராப்ரியேட் பிளேஸில் பேஸ்ட் பண்ணி இதை வந்து நீங்கள் வந்து கரெக்டாக இருக்குன்னா கிராஸ் செக் பண்ணி எவ்ரி டைம். ஸோ எனக்கு வந்து ஒவ்வொரு டைமுமே ஒரு ஆன்டிபயோட்டிக் ஒரு ஆர்கானிசத்துக்கு அகேன்ஸ்ட்னா ஐ நீட் 1 2 3. இதுக்கு வந்து சினர்ஜி பிளாட் என்ன செய்வாங்க. பட் என்கிட்ட ஃபர்ஸ்ட் டைம் காணிக்க சினர்ஜி பிளாட் கூட இப்போ வேண்டான்னு நான் நினைக்கிறேன்.
See, you can solve on your OneNote class notebook. Okay. So please solve on your OneNote class notebook. It will be easy for me to check. Aishwarya.
Yes, sir.
Have you solved or not? It's a matter of few seconds. I don't know why you are taking this much time. Aparna?
Sir, doing, sir.
Huh? Doing?
Yes, sir.
Oh, good. Okay, just do. So if anybody completed, you can tell. I'll tell how to solve that. I'm asking you to solve because it's a very simple formula, right? So you have to plug in 2 values. That's all. You'll get the answer.
நான் போறேன், இங்க பேப்பரை போட்டிருக்கான், இங்க பேப்பரை போட்டிருக்கான். இப்ப பார்த்தா வந்து நான் வந்து அப்படி வச்சிருக்கணும்னு தலைவர் அவனுக்கு இதெல்லாம் போய் அடிக்கி வச்சு அவன் படிக்கிற பையன் மாதிரி இமேஜ் எல்லாம் அவ்வளவு பேப்பர் அவன் போயிட்டான். இங்கிருந்த அந்த புக்கு பார்த்தாலே நல்லா தானே இருக்கு. உன்னை நல்லா வச்சுக்கணும்னு நினைக்கிறேன்டா. ஒரு அப்படி ஒரு இதாட்டு. சரி, வெரி நைஸ்.
Shall I tell how to solve? So are you people trying or 4:15? Okay, so the formula is 8.0 is equal to 7.4. Okay, pH is equal to pKa, right? So I'm writing pKa is equal to anybody solved? So can we rewrite this equation as pKa is equal to pH? Am I audible or not?
Yes, sir.
Yes, right. So my question is, I just copy this, right? So can we rewrite this equation? Sorry. Yeah. So can we rewrite this equation? I just copy this. Yes. So can we rewrite this equation as I need pKa in the left hand side. How to rewrite this equation? Shashank. pKa is equal to pH. What will happen for this term?
Minus, sir.
Hmm?
Minus log base form by acid.
Okay, so if I need the same plus, what should I do?
Sir, acid by base.
Log?
Acid by base.
So can I write like acid form by base form?
Yes, sir.
Yes, sir.
Is it right? What I have written is right or wrong? I'm not good in math. You have to tell.
Yes, sir. It's right, sir.
It's right. Okay. So can you now just the pK value is given. What's the pK value? The pK is equal to 8.0 and pH is equal to
7.4.
7.4. If I say pH is 7.4, so what is the biological so we discussed about different part of the body having different pH, right? So which fluid is having the pH around 7.4? Which biological fluid?
Blood plasma, sir.
Blood plasma, right? So here we are talking about, so if we put this molecule in blood, if this drug molecule in blood, how much percentage of the molecule will be in its ionized state? Okay, that's the idea of this calculation. So the pK is given as 8.0 is equal to the pH is 7.4 plus log acid form over base form. That's all. So can you solve this and tell me the value?
So is it 25%?
Don't first tell the percentage, right? So can you first solve for this before going for percentage calculation? What will be the value for acid by base, acid form by base form? Is equal to? So you'll get some value for the numerator and denominator, right? So what's the value? Solve this equation for acid over base. What will be the value?
3.98.
3.98 is absolutely right. Who's that?
Gautam Krishna.
Okay. Oh, good. Very good. So everyone getting 3.98? If so, we can go for the next step.
Yes, sir.
Yes, right. So, okay. So what's the another name for acid form? So here I have mentioned, three ways we can write. What's the another name for in terms of ionization?
Sir,
Or in
unionized.
terms of
Unionized.
acid form is unionized, right? So okay, very good. So the acid form is unionized and the base form is ionized. Both are same. I hope I am not confusing you, right? So acid form is unionized form and base form is ionized form, right? So okay, so can we say that for every 3 point, okay, so let me write it here. Yeah, so can we say that for every one ionized molecule, 3.98 molecule will be in its unionized form?
Sir, can you come again, sir? I didn't notice that.
Am I audible? Aishwarya,
So you're audible, sir.
Yes,
you're
sir.
audible,
can I
sir.
make a statement that if you say this value is 3.98, can I make a statement like for every one molecule in its ionized form, there will be 3.98 molecule in its unionized form? Again,
Yes,
I
sir.
repeat, for every one ionized molecule, there will be 3.98 molecule in its unionized form.
Yes, sir.
Yes, sir.
That's what we can understand from this, right? Aparna.
Yes, sir.
Yes, right. So if we want to convert now this into percentage, because in the problem we had to calculate the percentage ionization of this molecule. Percentage ionization. So how will you calculate the percentage ionization now? How will you calculate the percentage ionization? We had to calculate the percentage ionization from this value, right? So how to calculate that? See, so far our understanding is for every molecule in its ionized form, 3.98 molecule will be in its unionized form. How to calculate this into percentage ionization? So definitely we have to do something with multiplying by 100. Do you
Yes, sir.
agree?
For 1, it's 3.9.
What else we have to do? What?
Yes, sir.
Hmm.
Can I just solve it and tell?
So what I have to do? I am asking you.
No, sir.
Huh?
For one molecule, we have.
Say, okay, what I need is
Yes, sir.
percentage acid form. That's all. I just make it clear. What is the percentage acid form? Can you tell me the number?
Sir,
That's all.
1 by 3.98 into 100, sir.
1 by 3.98
100.
into? Can you tell me the percentage? The percentage value?
25.1 minutes, sir.
25 point?
25.125, sir.
1 to 5. Okay, it's wrong. And any other answer? I need percentage acid form. How many number of how much percentage of the molecule will be in its acid form? That's all. You know what is meant by acid form? Acid form is unionized form.
Can you guys hear me? Okay. So you guys are fine?
Anybody?
Okay. So first I want to appreciate because I received the manuscript from.
Sir, is it 75%?
Is it 70?
75%.
7. Can you speak a little loud? 70?
75%, sir. Just because if 25.
70%. Can you tell how you calculated?
Yes, sir.
I'm not saying whether it is right or wrong.
Yes, sir. If 25% of it is the that is by calculation we get it's 100 by 3.98 is the percentage of how much it is ionized, sir. So for acid form, then it must be 100 minus of that one, the value we got. Is it correct?
The level of writing is quite good, but not.
Am I
20 exactly. You're getting 25%.
Personally feel it's not enough.
No, so 25 point something will be 112 something.
25.12.
It was well organized. For me, it should be if somebody sends me any manuscript or whatever for correction, it should be in a very organized mode. So that I could get from you guys. So I was so happy. But when I was reading, it was like writing.
Okay, if I write like this, so you just tell me what is your understanding, right? So percentage of acid form is equal to 3.98. You know how I am writing 3.98, right? So into 100, I have to calculate the percentage by 4.98. What I'm doing here?
I felt it has to be really changed. So you have to rework on that. But otherwise, I'm happy. So this may not be.
So what is this 4.98?
Sir, concentration of the acid form divided by the total concentration, sir.
Total, right? So if you do this, what will be the percentage?
Works they have done. So we don't have time apart from
79.9%.
79.9%, right? So absolutely right. Again, I repeat, right? So some of you, this is what is this 3.98? This is the number of molecules that will be in its
Unionized.
here acid
Unionized
or
form.
acid form, right? So this is the number of molecule in acid form. What is this 4.98? This is the total number of molecules. Am I right?
why don't you people rewrite this entire manuscript?
Am I right or wrong?
Yes, sir.
Yes, right. So into 100, right? So this value is now going to be the number of molecules which are present in its acid form. This is the way how we have to calculate the percentage of molecules which is in acid form or ionized form or unionized form. Does it make sense?
Yes, sir.
So what is our understanding from this value, right? So 75.9% of the molecule, if you take 100%, among the 100%, 79.9% of the molecule will be in its acid form. Does it make sense?
Yes,
Does
sir.
it make sense?
Yes, yes.
So which means that 79.9% of the molecules will be in its unionized form. Am I right?
Yes, sir.
So how much percentage will be in its ionized form?
20% or 21%.
100
20
minus 79.9%, which comes 20?
20.1.
20.1 percentage. Am I right?
Yes, sir. Yes,
Is
sir.
it understandable? Okay, so coming to the the application part of this, what I mean is, so if you put this molecule in blood or plasma, how much percentage of the molecule will be in its ionized form? How much percentage will be in its unionized form? Can you people respond? If I put this molecule in blood, how much percentage of the molecule will be in its unionized form?
So same 79.9%.
79.9% will be in its
Ionized.
unionized form, and 20.1% will be in its
Ionized.
ionized form. Is it understandable?
Yes, sir.
It has great meaning, right? So today, you just check your class notebook. Okay, I'll upload 2 or 3 problems. You just try to solve those problems.
In OneNote, sir.
And tomorrow's session, we'll see about the application of this. Is it fine?
Yes, sir.
Okay, yeah, okay. So you may have some doubt. We'll start with the discussion session in the next class, right? Because I think time is up, right? So I just want to wind up the session, right? So thank you.
Thank you.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.